Hello everyone, it's Akshay again, and in this video we are going to talk about EOQ, that is Economic Order Quantity. Now, to set some context, let's go back to our previous video in which we already discussed a couple of methods of inventory planning, that is the aggregate level inventory planning and the item level inventory planning. At aggregate level, inventory planning happens at a strategic level. However, on item level, the inventory planning happens at operational or sometimes at tactical level. Now, at item level, questions such as how much to order, when to order, what is the safety stock I need, such questions are answered. And we already started our series into how much to order. In how much to order, we have already discussed a couple of ways in which the quantity to order is determined. The first one was lot for lot, which we discussed in the last video, and the second one is fixed order quantity. Now, the fixed order quantity can be arrived at in a couple of ways. One is based on experience, which is just like this is what I have been doing for years, this is what I have been ordering and works perfectly well for me, and it's going on. And the second one is EOQ, Economic Order Quantity. So, to answer your question, what EOQ is, it is just a cost effective way of ordering fixed order quantity for replenishment. Let's crack on. Now, having set the context, let's go through this graph and the equation to understand how EOQ is calculated. I know it looks a little complex at first sight, but I promise you I'll run you step by step through everything and you would have a much better understanding of how EOQ is calculated. Okay, let's define the axis. On the right axis, we have order quantity, and on the y-axis, we have annual cost. Annual cost is the total cost that you'd incur. Order quantity is the amount of goods that you order in one order. So simply put, if the order quantity is low, you would have low carrying cost. If the order quantity is high, you would have high carrying cost. Now let's understand more about the calculation of carrying cost. How is the carrying cost calculated? Simply put, it is the dollar value of the units that you are carrying into the annual carrying cost rate as a percentage. Okay, let's assume you have a item worth $100 in your inventory, right? And that factor, that is the annual carrying cost as a percentage, is 5%. So if you were to carry that item in your warehouse for the entire year, your carrying cost would be 5%. At the end of the year, you would have to spend $5 extra to keep that $100 item in your warehouse. And that is how simply the carrying cost is calculated. Now, for this graph, if you have higher quantity, that is the more number of units in your warehouse, you would incur more carrying cost. Look, on the y-axis, it's the annual carrying cost, right? So if you have less number of units, you would have lower carrying cost. And as the order quantity increases, that is, as the number of units you keep in your warehouse increases, the annual cost of holding them will also increase. That's why it is a straight line, upward rising straight line. By the way, we have also discussed different inventory costs in one of our previous videos. So if you're not clear on what are different inventory costs, I highly recommend that you go through that video as well. Now let's take a look at the ordering cost as well, right? Now, before we go into that, let's also understand the difference between ordering quantity and the number of orders, right? So from our previous example, if I were to put 10 different orders for 100 units each, the number of orders are 10 and the order quantity is 100. And I order it in one go. The number of orders is 1 and the units are 1000. See, ultimately our monthly requirement is 1000. You can choose to go about that in any way you want, right? So I'm just taking two simple combinations, 1 into 1000 and 10 into 100. So in the second case, our ordering quantity is 100 and the number of orders are 10. Now this ordering cost totally depends on the number of orders. It has nothing to do with the order quantity per se. Although order quantity bears a negative correlation with number of orders, of course. I'm sure you have noticed by now that I'm trying to introduce these variables to you through the help of the graph as well. So ordering cost is the cost per order into number of orders. So when the order quantity is minimal, right? So let's say we are ordering, we have 10 different orders of 100 each, right? So there are 10 orders. So we have a very high number of orders. So we would have high ordering cost. However, at this end of the order cost, we're just putting one order of 1000 units, right? From our last example. So the number of order is just one. So the ordering cost is the minimal, right? So as the number of orders decrease, right, the order quantity increases and so does the ordering cost. Now, I hope the carrying cost and ordering cost are both clear to you now. Now, if you just make a simple observation that these graphs do intersect somewhere, and this intersection point is nothing but the EOQ, economic order quantity. The third graph that you see here is nothing but the summation of carrying cost and ordering cost, right? So if you are just to sum this point and this point, you'd get this point, just like that. And that graph is called as the total cost curve, which is summation of, again, carrying cost and ordering cost. The lowest point on this graph is where you get the economic order quantity, which also is the intersection point of these two graphs. This is how EOQ is calculated graphically. As we already discussed earlier, EOQ is nothing but the point wherein you get the minimum carrying cost and the ordering cost for a fixed amount of ordering quantity. Now let's try to understand this with the help of numerics as well. In order to calculate it numerically, how would we go about it? First thing first, let's understand the variables. One is the ordering cost per order, and I is the annual carrying cost as a percentage of value of the goods. Now let's also discuss the other variables that are discussed here other than I and S. We have Q, which is the quantity that we need to order, which is essentially the EOQ, right? And then there is C, which is the unit cost in dollars or unit cost of the item that we are going to order. And there is A, which is the annual usage in units. Now, in order to connect it to our previous examples, we assume that we wanted to order 1,000 units, right? And we took a combination of 1 into 1,000 or 10 orders of 100 each, right? So that 1,000 is the annual usage. Order quantity is either 100 or 1,000, right? In whichever combination we want to order. And C is simply the cost of that 1 unit of whatever we are ordering. So I hope all these variables are a little clearer to you now. Now let's jump into the equation. In order to calculate EOQ, we want to minimize the total carrying and ordering cost. So we simply equate the equations. So how is the ordering cost calculated? It simply is the annual usage in units, that is A, that is the 1,000 we had earlier, right? Divided by the quantity we want to order. That will give us the number of orders. A divided by Q gives us the number of orders, and S is the ordering cost per order. And that is how we get the ordering cost. The average inventory in my warehouse is nothing but Q by 2. That is the quantity I order, 100 divided by 2. That is 100 by 2 is 50. So if I decide to order 1,000 units, I would have 500 as the average inventory. If I decide to order 100 units, I would have 50 as my average inventory. So Q by 2 gives you the average inventory in the warehouse. Now that is in terms of units. You multiply that units with the unit cost in dollars or whatever the unit cost of any currency for that matter, right? So number of units, that is the average inventory in warehouse multiplied by C will give you the total value of the goods in the warehouse. And as we discussed earlier, the carrying cost is nothing but the total value of goods into the annual carrying cost percentage. So the total value of goods in the warehouse into annual carrying cost as a percentage gives us the carrying cost. Now after that, it's just a matter of solving the equation. Now we just take Q to the left hand side and we take all other quantities to the right hand side. So we would get an equation somewhat like Q square is equal to A into S. This 2 goes to the numerator. A into S into 2 divided by this I and C go into denominator. That is divided by I and C. So the equation would be Q square is equal to A into S into 2 divided by IC. That was Q square, but we want Q. So simply put, we'll just take the square root of both sides and we'll get EOQ, that is the value of Q after solving that, this equation equal to under root of 2AS by IC. And that is how, my friends, EOQ is calculated. But the important message that I would just like to give you is that it is nothing but equating carrying cost and ordering cost, and EOQ is nothing but the quantity that gives you the lowest carrying and ordering cost. Now, EOQ is certainly very useful, but there are again some limitations with it. So in this slide, we're going to discuss about what are the assumptions. So the first assumption is that the demand is known and constant. If you remember, I had assumed that the annual demand is 1,000 and I kind of hoped that it would be same throughout, which is generally not the case. The second assumption is that the lead time is constant and known. Now, if you remember, we had also taken an example of ordering 100 units 10 times, that is a 10 orders of 100 each. And I assume that every time our 100 units come to an end, we would get an order, but the lead times generally change. Simply put, the calculation of EOQ does not consider this lead time change or even the demand change that we just discussed. The third assumption is that there are no quantity discounts. So whenever you go to a supplier and you generally buy in bulk, you get certain discounts. For example, if you were to buy 100, you would get 5% discount. If you were to buy 500, you would get around 10% discount. And if you were to buy 1,000, you would get around 15% discount. If such a discount slab is available, EOQ model does not consider it. And finally, the last one, the only two variable costs that EOQ considers are carrying cost and ordering cost and simply equates them. However, in real life, there are other variable costs such as transportation cost also. For this video, we'll just limit our discussion to EOQ. So these are all the EOQ assumptions. And I hope that this video shed some more light on your understanding of EOQ, how it is calculated, and when and where to use it. Thank you so much. This is Akshay, and I'll see you in the next video of our inventory series. Have a good day.